If you are a BCA or engineering student preparing for tech placements right now, we need to look closely at the corporate earnings reports that just dropped this month. The baseline economics of the entry-level software job have shifted. Autonomous digital factories now assemble complex structural components at speeds a human cannot physically match. Look at Google's specific corporate disclosure. In their latest earnings call, Sundar Pichai confirmed that artificial intelligence now generates 75% of all new codebase additions at the company. When a machine generates 3 out of every 4 lines of code, the human ability to recall specific Python syntax becomes a redundant skill. This high rate of automation renders the traditional university placement strategy based on memorizing syntax and building basic front-end clones functionally obsolete. As an entry-level candidate, you might assume your primary value to a company is the ability to write code. But to a tech giant, basic code generation is now a free, infinite, and instantaneous baseline capability. Preparing to be a human syntax generator means you are actively training for a job function that has already been automated. Historically, the junior developer acted essentially as a human compiler, a typist whose primary function was the manual generation of syntax to translate ideas into software. Enterprise companies are no longer paying for typists. They are aggressively hiring for code governors and system architects. The cognitive load of the job has inverted. Instead of focusing your brainpower on writing code line by line, you are now required to orchestrate autonomous digital task forces to build entire systems. Look at this timeline comparing the standard software development lifecycle. In 2023, 80% of time was dedicated to manually writing code. By 2026, generation is virtually instantaneous, replaced by a massive block for reviewing AI output. This phase is extended because machines produce immense volume. Engineers must now sift through thousands of generated lines. A modern engineer's value is dictated strictly by their ability to orchestrate and audit these AI agents, not by their typing speed. To understand the scale of this new workflow, consider that an AI agent can comfortably write and submit a 3,000-line pull request in seconds. This creates a literal flood of data, an overwhelming deluge of interconnected structural blocks, instantly stacking into massive monolithic systems without any human intervention. Human developers cannot compete on volume. Attempting to outtype or outproduce a machine in raw syntax is mathematically impossible. Instead, the process creates 3 distinct human bottlenecks. First, companies need engineers with the expertise to spot logical hallucinations deeply buried inside these massive machine-generated code blocks. Second, someone must manually verify the underlying data structures and ensure they are sound before anything is actually compiled. Third, rigorous security auditing is required to integrate this AI output safely into a live production-scale environment. The primary engineering challenge has shifted. It is no longer about the creation of code, but the secure containment and integration of infinite machine output. Because AI generates code so quickly, many students panic. They try to keep up by rapidly deploying complex frameworks, relying on the AI without understanding the math. This leads to faking the fundamentals on a resume. A very common red flag is bundling neural networks and deep learning together, treating them as identical concepts just because an AI grouped them in a boilerplate script. This diagram shows why. On the left, a simple 3-layer neural network requires calculating weights and biases. On the right, a deep learning architecture with recurrent loops introduces opaque hidden layers and high deployment risks. They require distinct architectural approaches. If you treat these as the exact same concept during a technical interview, a senior engineer will instantly know you are just blindly pasting unverified AI code. The faster AI tools generate code, the higher the industry premium placed on the rigorous foundational mathematical knowledge required to audit it. To survive these placements, you must completely abandon the model of reading textbooks just to memorize standard programming syntax. You have to pivot immediately to project-based learning, utilizing modern, AI-integrated IDE platforms like Cursor or Windsurf. Look at this layout of a modern AI workspace. You have a clear boundary. The sidebar handles natural language inputs, while the central window displays the complex architectural outputs the machine builds. This setup allows you to practice vibe coding. You use natural language strictly to generate the AI to generate all the necessary boilerplate text. For example, You can initiate a complex machine learning pipeline build from scratch, allocating 100% of the actual typing to the AI agent. While the machine handles the syntax, the human engineer must retain total control over defining the exact data flow and logic of the system. Viable technical preparation now requires actively practicing system design and orchestration rather than relying on passive memorization. Once the code is generated, the first mandatory human responsibility in this new pipeline is establishing strict security guardrails around the data flow. The second mandatory responsibility is manually analyzing and actively optimizing the algorithmic efficiency of the machine's raw output. This directly addresses the overarching industry fear that artificial intelligence will lead to the complete eradication of software engineering jobs. The industry will always need a human presence capable of stepping in to organize the chaos, directing raw computational power into a structured, functioning system. The software engineering profession is increasingly concentrated at this architectural level. Engineers who master system design and orchestration will claim the high-value roles that syntax-focused developers are currently